Hello.
Hi, Zach.
Hey, working on setting up my headphone system and it is not liking me today, but how's it going, Ricky?
So far, so good.
Excellent. Think that'll work. Nice.
Yeah.
All right, let me go ahead and post in the Discord here. How far along in the book are you?
I just joined, so trying to catch up.
Makes sense. All good. I'm going to be posting all of my notes that I'm coming up with in the Discord here, probably either after the meeting or I could do it now.
Oh, all right, cool.
Let me go ahead and get those out. Hey, Kevin. Possibly. Hey, Kevin. How's it going?
Good. How are you doing?
Pretty good. Pretty good.
Does it show me when I'm struggling with my audio over here, like before I like join my audio?
No, mine did the
okay.
same, and I'm very glad it didn't show me because I'm now like I've got my Yeti microphone going. Or no, it's coming out through my speakers on my desktop, and it's going through my headphones that don't do echo.
Oh gosh.
It is the most
okay.
janky system because I could not find my headphone cord, and the Bluetooth doesn't work very well because my computer's under the desk.
Gotcha.
But how far along in the book are you so far, Kevin?
I've got through the first like 5 chapters.
Okay.
So
nice.
Yeah, I've been reading. Hiromi and I've been reading it together as well.
Nice.
So yeah.
What do you think of it coming from Fast AI?
I just feel bad. Now I think that there's some really good things to think about from it that I'm like, oh yeah, I don't do that very well.
Yeah, I've shown this book to Hamill, Radek, and Wasim at this point, and all of us have kind of done oh, I see.
Yeah.
That makes sense. So welcome, Santiago. Welcome, Purity. The cat in the background is Max. For
Hello, Max.
all of you wondering, because I know you are. How far did each of you get through the book? I meant to send out a questionnaire just asking like where everyone is. So far, we've got a few of us like up through chapter 5. I've read the book, but I reread through like the first 2 chapters or so.
Yeah, I mean, starting chapter 3. Yeah.
Okay, chapter 3, not bad. Welcome, Manic. I hope I'm pronouncing that right.
It's Mayank.
Manic. Okay, excellent. Welcome.
Thanks.
I'll give everyone a few more minutes to hop in and then we will begin. I did post my notes. If you guys want a few notes to look at, I'll be editing these live as we go through sort of some of the points and kind of what my idea was. We go through the first few chapters, talk about sort of the ideas behind it, and then from my end, what I thought would be good code bases to study, as some of you might have joined in during the middle of that conversation, is looking at the FastAI code base, because it's a very good example of talking about the pain points that this book talks about quite often. And then also looking at some of the Hugging Face libraries that I'm familiar with that I work on. So like we'll look at Accelerate because it's very bare bones, not very magical. And we can see where even Hugging Face we tend to struggle on some points with in terms of complexity. And then maybe Transformers too, although that's a much bigger code base. Let me go ahead and start recording. Hey, Eugene. Awesome to see you here.
Morning, Zach.
Oh, nice. It's already recording. How far in the book are you, Eugene, or did you already finish it?
I just started chapter 5 yesterday.
Nice.
But yeah, it's a really easy read. I really like it.
Yeah, somehow it took me 4 months to read this thing because it took me 3 months to get through the first chapter, and then I stopped for 3 weeks, and then I read the rest in a single night.
Nice. Yeah, it is a good read. Thank you for giving me the reason to read it.
No problem. Honestly, it gave me a good reason to go back into it because this book is also kind of like some of the foundation that I want to do for the next course, but I want to make sure I fully get it, and like study groups help phenomenally with that. So it's like, hey, why not? We'll all study together. So
Agreed.
So I guess if we want to like summarize it for the folks that, maybe haven't quite read the book yet or getting there. Chapter 1 and 2 mostly talked about, so here, let me go ahead and share my screen here so we can look at my notes. There's a link to my notes in the, maybe I could share my screen. In the Discord. There we go. Big green button. That would help. But just in case, I've got the notes all over here as well for us to take a look at. And so some of the stuff I've written down is a big part it mentioned is we want to simplify code. And so that's by eliminating complexity. And generally, and I know it has its own definition of complexity, right? Anything that makes it challenging to comprehend or modify. The annoying part I found when trying to think of like this definition is, well, that changes based on everyone's experience, right? Because, say you're 10 years into your software engineering career at this point, complex code bases might seem simple to you, but, it's not going to be simple to like someone a year in. And so where does that balance lie? Because also the harder the problem is, the harder it's going to be to define what is simple for a code base. Like if you think about Transformers, it has, this policy of do repeat yourself. And so you have model definitions that are like the same code written over and over and over again, leading to 1.5 million different files that you have to go read into. But then on the flip side, you have like FastAI that really stayed focused on dry, right? Don't repeat yourself. And it's a code base that's exceedingly difficult to navigate. So what, like, in your guys' experience, have been code bases where you would say it's pretty simple to understand? And if you have any where it's like, well, I think this is pretty simple, and then you talk to other people and you realize like, this is not actually that simple of a code base. I've just existed in it for too long.
FastAI. NBDev too. Same.
Yeah, those are definitely some ones where I even have them up here of if we want to take a look at them. If you're not familiar with FastAI, It's a machine learning framework built by Jeremy Howard and Sylvain Gougerin and a million other people that abuses anything Python can. So like you have import star everywhere. You have magic happening all over the place. It's a very difficult framework to learn. And unless you stop using the framework, you don't realize how complicated the framework is.
I think the import star is really I think that adds a lot to the unknown category of things, because you'll just end up with like functions that just exist, and it's like, where did this come from? And especially if it's coming from a different like those are less magical because they're at least in the same code, like the same repository. But if it's importing star from fastcore, you have to actually like go to a whole different repository to search to see like, where is this function actually being generated and coming from? That's something that like I think it adds to that.
Yeah, like I'm here on like an official Vision tutorial, right? And the first line is from fastai.vision.all import star. And you don't know where anything comes from after that. You just assume that everything defined in this tutorial comes from this nested import star, and also has like monkey patches in there too, to make it even more complicated to follow.
Yeah, like it's nice for moving quickly, but it makes like I've basically started removing all of that. We have a internal code base that uses a similar structure because it's kind of built like from people that were mostly familiar with fast AI. I've been just like slowly ripping out all of the stars and being like, all right, what's this actually doing? And it's interesting how often I find stuff that is like, this isn't what I thought it was importing. Like there'll be, maybe like 2 import stars, one above and one right below it. That's like, if you would switch that order of that, it would completely change what's happening in the code below.
Absolutely. Like, this isn't a very good example of it, but there's a few times where like I've translated the from FastAI Vision all. This is a free course that I have, and brought in everything we wind up using. And in some cases, like I'll have this from FastAI learner import learner, and then you have to import learner again to bring in monkey patches for it, which adds a lot of complexity to the user, because on top of like understanding where everything comes from, debugging becomes a nightmare. Now, like if you structure your code like this, it can help some from like a user reading your code, but that's only one part of it, right? Kevin, I'm sure you've faced when FastAI breaks the stack traces, and trying to find the stems for everything is a nightmare.
Oh yeah. The other one thing when you're trying to figure out like where does a function come from, if you just type the function by itself, just in case anybody like is trying to do this, you can actually see like the library it's actually coming from in the like signature that shows up. If you just say like, get image files, enter, don't put any parentheses or anything, it'll actually give you a better idea of like what is get image file, where is it coming from, and then it makes it easier to like actually go from that top cell to the bottom cell too.
Yeah. Now, the other part of that though is just don't do this. Like I've thought about rewriting FastAI from the ground up without using fancy magic, and it's possible. I just haven't had the right motivation to do that yet. Because it can be a library as powerful as, say, PyTorch Lightning or Hugging Face Transformers, with the added benefit of a clean code base. If it adhered to more of the philosophies in this book rather than clean code. Because if you've read through the book far enough by this point, I think at one point he directly calls out clean code. It's like, we're going to talk about this because this is wrong. It was right for some things, but especially for like Python programmers, clean code and having an almost cult-like following to dry that it sort of insinuates in you can lead to really complicated frameworks. Let me see what the next one is. So next point was modular design. So in the group 1 code base that I posted for this week, you'll notice that it's basically the PyTorch MNIST example written out fully as one file. The goal with modular design and what I want you guys to like, if you feel like it, try and do with this is come up with a modular type framework for PyTorch, right? A small little wrapper framework. But try and tie it into what the chapters talk about as sort of practice, and more ideas will stem on it, of course. But the idea with modular design is you separate out ideas based on what they're about. So like you could say have one file or one module that's based on like just building models, right? So setting up nn.modules, another one based on like setting up schedulers and different learning rates, another one for optimizers. And sort of what the book talks about is balancing these two ideas to the point where we don't oversimplify code to make it more complex, but we also don't over-modularize code to also make it more complex. And it does this by mentioning a few symptoms. So one of them is what's called change amplification. So that's simple changes to any part of the code base requires changing a lot of different things. So that could be like you're adding one, say, parameter to a function. If changing that one parameter requires then adding that to like, say, the function signature of 16 other functions in your code base, that's not good. That's a bad code smell because one little thing is having to change like 12 different functions. 2 or 3, I think is okay. I've dealt with that at work where we were dealing with like big model inference and PyTorch added this new capability and we had to trickle down this new parameter across 16 different functions. And it just wound up not really working well. And what winds up happening in our code bases is if we notice this, what usually winds up happening instead is after about the 3rd parameter, we create a config class instead. In that way, any changes all just need to be modified with one data class. And there's no function signatures that need to be changed or anything to sort of mitigate this change amplification part. The next one it talked about is cognitive load. And that's basically how much a developer needs to know reading the code base to understand what's going on. Because tutorials can get you far. And if you have good, clean docs with a complex code base, it's okay. It's not the end of the world. I'm pretty sure there's even a quote in the book of talking about how if there's complex code, but it's only on the back end and the user never sees it, it's still a low cognitive load because the user doesn't have to worry about any of that. Whereas if, say, a user hits a bug and it exposes some of that complicated back end, though, then that is a high cognitive load because they're having to understand a lot about this code base just to be able to debug what their issue is. Or a lot of times maintainers don't even know how they got there, where the issue comes from, and they don't even understand their own system because they don't even understand the cognitive load. Which leads to the 3rd issue, or the 3rd point it mentions, unknown unknowns. And that's not really knowing what you need to do after a certain point to fully execute on the problem you want to do. To relate it back to fast AI, because a lot of us here are familiar with it, unknown unknowns happen a lot with FastAI's layered API, because it basically has 3 ways for you to make data loaders, essentially, based on like if you're doing computer vision or you're doing tabular. And it has nice one-liners that basically just say, here, call this class with a constructor, and you can be on your way. If we go down to here, it's this nice image data loaders from namefunc and pass in a few things to help build it. The second you go from this to the mid-level API or the low-level API, the cognitive load increases exponentially. And the second you have a problem that can't go beautifully in this one-liner, you go from, I can learn FastAI in 10, 20 minutes, run one of these tutorials and I'm done, to it can take days to fully learn it. And so when designing sort of APIs like this, it's important to keep in mind, okay, as a new user, how do I make sure that people can hack this code and understand what's going on, but still make it efficient? That's actually one of the things that we have to be very careful about in Accelerate, because Accelerate is designed to be a low-level API PyTorch wrapper that lets you send code on GPU, TPU, and whatnot without changing anything, or almost anything. And what winds up happening is if we introduce any magic, any added complexity that PyTorch didn't have in the first place, it can't belong in the framework. And so it's this tug of war with API design of, well, okay, I want users to do this nice, cool thing, but how do I make sure that A, stack traces don't get jumbled and reading the code becomes a mess, and B, is it actually simpler than just having them do the thing manually? And so these are sort of the 3 ideas of a complex code base, because you can write wrappers for ages and have this beautiful code that, you know, is just fit and go. But if users can't debug it, understanding what's actually happening is confusing. And on top of that, you know, changing one parameter in one function spirals out of control and you have to change 17 different functions as a result. These are sort of the ideas of complexity that the book talks about. And it takes a more extreme approach to stopping this with a 0 tolerance philosophy. So if any signs of any of these 3 exist, we stop everything and address the problem. I don't know. In my opinion, like, that can be hard to judge, and you kind of need an outside person from your framework or whatever you're building, not at first, but especially when you're a few months in, or, you know, a year into building this API, because it can get very easy to be lost in, well, I understand this framework, and, you know, my main active users understand this framework. It must still be going good, because it's so easy to lose that beginner mindset. One thing I tend to do fairly often that helps with it is I either have straight up non-tech friends that I'll be like, hey, I have this idea, and basically try and describe it in the most simplistic terms possible and see if that sounds to me too complex, or if they have ideas. Because more often than not, like, if you can figure out how to describe a problem or a code base using simple terms, even people not experienced in tech but are like experienced in problem solving can kind of help you smell problem areas a bit easier. Yeah, I just have some examples of cognitive load here. So like FastCore and FastAI use a lot of Python magic. Honestly, to the point where I think
the stack traces don't look very clean in that, like that.
No, it's all a nightmare to use. That doesn't mean don't use
I was gonna ask you, Zach. So
Sure.
You mentioned using configs to like kind of I guess reduce the amount of places that you have to change code. But I mean, if you add a new config, like if you add a new parameter or whatever, if you add a new attribute, don't you still have to propagate that through to like wherever you're using the config? And then like, I don't know, I guess does that just trade off like the first type of complexity for more cognitive load of like, now I have to remember what all's happening in this config?
Well, no, not necessarily, because the config should just be a data class, right? When I say config, I just mean a raw data class. And so as long as you're passing this data class throughout all your functions and whatever you're doing, say only one function actually needs this new parameter that I'm trying to add, I just add that in one location. But if that one function is like 6 functions deep or whatever, I would have to, if I didn't do the config, add that function 6 layers
I
deep,
see.
or add that parameter 6 layers deep versus just calling the data class and its attribute when I need it.
Is it, do you find it better to use like a explicit config versus using like kwargs?
That's a discussion that we've talked about in Transformers quite a bit. Accelerate tends to use explicit configs. I am kind of, I have PTSD from kwargs, one could say, from FastAI, because it will use kwargs and special wrapper decorators to populate them. And that works in a standard Jupyter notebook compute environment, but tends to break fairly often when you're using like VS Code. And also kwargs can be a bit weird. Like I can show you some examples in Accelerate of what we do. So like if we take the main accelerator class, so we have like project configuration, we have like gradient accumulation plugins and different, like we have, I think probably 9 different configs at this point, because there's so many different things you have to deal with when dealing with distributed compute. Like we have one for deep speed, one for fully sharded data parallelism, one for just logging. And if we didn't have these plugins and these different configuration classes, the function signature for accelerator would be like probably 100 deep at this point. Just because like sometimes you're going to use FSDP, sometimes you're going to use deep speed, sometimes you're going to use none. And if you don't do that, right, it's just going to be a huge mess. But also if you just use kwargs, unless your kwargs are going to one point, one specific place, if you're using like anything that requires like specific keys to figure out where XYZ needs to go, that just becomes a mess. So you can use kwargs if it's going to one location and one location only, I would say. And like what can go in kwargs is very specific. Like this isn't to say that we don't use kwargs in Accelerate. Like I think the accelerator even has kwargs at some point, or at least I thought it did. Looks like it doesn't.
What is the kwargs handler?
What is what?
I saw that in your class signature, whereby you had all the 9 different configs. You had this thing called kwargs handler.
Oh,
What does
kwargs
that
handler.
do?
Where did I see that?
Line
260.
265. Yeah.
Yeah,
Yeah, so like over here. So these are
Yeah.
like line 265.
265, yeah.
So kwargs handlers are basically, we go over kwargs handlers. This is just a class that basically lets you set things up as take data classes and call 2 kwargs, which turns them into dictionaries very easily.
Gotcha,
Like,
thank you.
if we look at kwargs handlers, every single thing ending in kwargs uses a kwargs handler in Accelerate, just so that way we can convert it to a dictionary easily. but it's still at the end of the day a basic data class. It just has a toDict function that we can call.
Gotcha, makes sense. Thank you.
No problem. Yeah, does that answer all of your question in full? I guess, Kevin?
Yeah, I think so. I think the other thing, just from seeing what you're doing there,
Yeah,
is quarks, you don't really know what's available. Like even like you can't tab complete it or anything. But if you know, like, I can pass this class to this function, you can like explore what's available, what arguments do I have in this config that I could actually mess around with. You kind of gives you a little bit of a hint of like what types of things are available for manipulation.
yeah, and because you can keep that in native like Python code as well, it's documented, because assuming you document your data class properly, right? Like maybe not here, but there's a few other places where we talk about, yeah, so like we have enums that are very specific, or you just document, your data class, and VS Code knows how to pull that up. So anytime you hover over like what is project config, it'll tell you all of these different doc strings. Whereas if you just have like quarks, you either hope that it's defined somewhere in the doc string, and even if it's defined in the doc string, you still have to find where that actually is. So it's just better to use a data class or some form of configuration management tool, because there's other things besides data classes that people use. Just with Accelerate, we tend to be very limited on what we use as dependencies. So everything is pretty much raw Python or standard lib, unless there's very specific reasons. Let's see, so where were we at after that? Sounds like a few of us went into chapter 3, so I guess we can talk about chapter 3 and then open it up to, actually, unless there's other discussions that we want to open up first, feel free. If anyone has anything they'd like to talk about, vent about, anything related to the book. All right. We can talk about chapter 3 then for a little bit, and then use this space to kind of like, if you want to go reread through the chapter, come up with any questions or chapters. Chapter 3 mostly talked about this idea of tactical programming. And essentially what that is rather than this approach of work fast and break things, right? Like, for example, startups love to do that. They can love to come up with new features really, really quickly, and they tend to be very unstable, especially with new code frameworks, as they're coming up with different ideas and trying and seeing what works. I think it's like move fast and break things is what they say. And the other approach to this is this tactical mindset that the book talks about, where you think before anything else of just what's the design going to be, right? How does this design operate relative to the rest of this code base? How is this design going to think and operate and feel 3 months from now? Am I actually going to like it? And then it thinks about, okay, how can I write good docs for this? Right? Well, what would good docs look like? How much good documentation am I going to need? And what winds up happening is this is a bit slower, right? Because rather than going with the first idea you think of, you actually have to sit there and work with it for a little while, truly think about, is there better ways that we can do this? What I tend to do as well is, if I come up with an idea, I'll go to my team and I'll be like, hey guys, here's an idea for this. Rip it to shreds. Tell me every single flaw you see in this, and then tell me the good. Because I already know the good exists. I don't need validation, right? Because it's my idea. I have pride in it, and I'm assuming this is good. but I want to make sure that it's easy for the other experts in my framework to know. And if it's easy for them to know, then make sure I can write documentation easily enough for it. And if I can, then it's probably a good idea. And it mentions often leads to technical debt, where time is borrowed from the future, resulting in slower development because we're sacrificing more time now to assume that it's going to pay off later, and assume that the technical debt that comes later from fixing or tweaking or whatever we're doing with this isn't going to be as bad as if we went with the first idea that came to our head. And it sort of talks about move fast with solid infrastructure. And so that's, the strong foundational idea of taking time to fully understand the problem, understanding the design of what you're trying to do and executing it, along with having it be simplistic enough or fast enough for you to implement, that it's a strong code base that has been through rigorous testing of just the design philosophy, and then finally you're fully integrating into the system. A very good example of this with Accelerate is when I mentioned earlier that we're not allowed to use magic. Magic and Accelerate is very different than magic in, say, FastAI. FastAI magic is all over the place. It's embedded into the framework. Magic for us is if anything is unclear at any point in time of the user trying to do something, if there's a hidden function call behind the scenes, anything like that they wouldn't expect, that by definition is magic. So I don't know, I think 8 or 9 months ago, I was working with Sylvan on trying to write this gradient accumulation wrapper. Because in distributed compute, you wind up having to do a few extra things. I can actually bring up some docs about this because it talks about it. So whenever you're doing gradient accumulation, you have to worry about this thing called nosync in DDP. And basically, all that you guys need to care about is when you do the backward pass, if you're on distributed compute, everything has to freeze until every model has performed their backward pass. And so usually every node is a little ahead of the other one, or things are out of sync for a bit. But it's a time waste if, say, you're doing gradient accumulation where you call backward, but you are accumulating the gradients, right? You're not actually performing the full synchronization of everything. You're synchronizing every time, which can lead to a huge slowdown. And so what you do instead is something like this, where you say, if I'm not synchronizing, right, we're not on the last step of gradient accumulation, I use this thing called nosync, do my backward pass, otherwise do the full sync and the full optimizer step. And I wanted a way for you to do that automatically, or some would say automagically, using accumulate, right? Because this is a lot easier for you to use. It requires no code changes. You just add this thing in here and tell Accelerate, hey, I want to use XYZ gradient accumulation steps. I think I iterated with Sylvan about 16 times on the design of this thing to finally come up with something that looks magical in itself, but is actually the least magical thing we could come up with. And it really required Sylvan grounding the rules of, we cannot allow magic. That is your limitation. Good luck. I had to rely on some people that never have used Accelerate in Hugging Face before to say, hey, I think this idea is good. What do you think of the framework? Is it easy to understand? And as a result, it's been in the framework ever since, and people have used it with minimal issues. And if anything, we're actually expanding on it. We added the ability for more models, because that was the thing that you can do apparently in DDP. And so working in this sort of iteration mindset of, it's okay to have the first idea for some things, but spend an extra week, spend an extra few days at least thinking about the design first, and then write tests, and then figure out docs. can really make a difference when you're building a framework, especially forcing yourself to be in the mindset of other people versus maintaining a very opinionated or self-fulfilling mindset, because it fixes your problem in the framework, but it could lead to, you know, other people having more problems. Right. So that's sort of what this chapter in a nutshell talked about. And I'm sure you can think of examples where adding new features can lead to, you know, different issues. Like a very common idea with this is, and especially with this idea of technical programming, is when you deal with deprecations and breaking changes, because if you have a breaking change that's introduced due to your tactical programming mindset, it needs to be carefully addressed, right? Because the idea is still going back to cognitive load. We need to make sure that it can lead to a quick payoff of, hey, this actually isn't needed anymore, let's fully deprecate this. But also, A, give users enough time to fully get away from it, and B, give them clear errors when you do fully deprecate it, ideally, at least for a time, rather than just never assuming backwards compatibility, never assuming any sort of maintainability or stability in your framework. Those are just a few of my thoughts with chapter 3 as well. Any other thoughts or questions from you guys on these first few chapters?
I had a quick question
Sure.
to Zach and of course folks who have read it. I wondered, as I was reading this, I was wondering, is there an aspect of complexity whereby the abstraction does not quite fit what is actually happening in real life? For example, let me give you an example. So we can imagine in a hypothetical scenario, you have a data pipeline. To a developer, to a data engineer, a data pipeline is a single piece of abstraction, right? But you can imagine if you are asking the developer to write code for the data pipeline such that the abstraction is now separated into 7 pieces. For example, you have the code for the pipeline, you have the code for the data artifacts input, code for data artifacts output, you have the code for the scheduling, and you know the same code you can run on different marketplaces. Each of them is a job. So now you can see that there are very many pieces in the object-oriented world which people love. I am of the view that this is probably not the right abstraction, because to a user, there's always it's just a single item, but you're making me write code in these 7 places just to deploy this data pipeline. Now, the question I have is, I would love to hear pushback on why maybe I might be misunderstood that of how abstraction should be like. To me, it's very complex because in order to make one change, I have to write it all over the place. But maybe this is for the best. Is it too abstract? Should I pull up a visual example if I can?
If you have a visual, that'd always be helpful. But like, I don't know, and other people can chime in, like interrupt me, feel free. There's a balance, right? There's always a balance to everything. If the benefits of having the user perform this abstraction and like having to change 16 different things in order to introduce this new feature, I would hope that like the framework isn't like a 1.x.x or something if we're introducing such a complex thing. And also if the benefits of doing so just make sense. But at the same time, like, I would hope that they would come up with something better. I don't know, that smells bad to me.
My intuition is along the same way. Usually, every time I push them for this, it's like, hey, we're gonna be able to reuse some of these components across, but there's no way you're gonna reuse anything across. You're never gonna reuse the same logic for a different job. The only thing that can be reused are the data loaders and the data outputs, because that can be reused. The same job you can imagine it like the same accelerate pipeline, right?
Mm-hmm.
I always wondered if it was just host disabled participant screen sharing. I always wondered if it was object-oriented approach going a little bit too far. So I always wondered if there were any folks here on this call who actually have more Java or Scala experience coming from that side of the family instead of the Python side of the family, who could weigh in.
You should be able to share now, by the way, Eugene.
I have, thank you.
Perfect.
So here's an example, right? This is not the best example, but you can imagine everything is just a data pipeline, whether you're training a model or whether you're processing them data. Everything is just a training pipeline. And you can imagine this thing in the middle, this DAG, that's the script. Now you can imagine that anything here that needs a data input, that's considered the input, and that would be a separate job. There will be a data input class, and then there will be this thing here would be the script class, and then this thing would run in different marketplaces. That would be the jobs class, where you have one job for every marketplace, and then you will need to schedule it, and that will be the scheduling class. So it makes sense that you can break down this thing into all these different things, and I think that's what the author calls classitis, I think, in one of the chapters.
Yep.
So when I read that, I was like, wow, this is really freaking familiar. But to me, but when I try to push back, I say, hey, look, guys, I can squeeze all of this into a single script, whereby every time a developer needs to change something, they just need to focus on this script. Everything is in here. But the pushback I get, that's 300 lines long. We want everything to be maximum 100 lines long. And then they break it apart. But then now this means that a new person coming in doesn't know that they need to change all these different things all over the place, which to me, that is the definition of one definition of complexity. And I guess it also speaks to the unknown unknowns and maybe the wrong abstraction. That is my view. And I don't need people to tell me that my view is right. I want people to push back against my view and help me see how the other view may be correct. And of course, if the other view is just completely off track, that's also fine if you can't push back against it.
I mean, I think one thing you could look at in the overall library is the concept, the class, or even if it's a function, is it used elsewhere? Like if it's not actually used elsewhere, or because that's what I see sometimes in the code that I'm working on, is there will be like 3 layers of abstraction, and it's only used in this vein. There's no other places where it gets used. And I think that's to me is like a really good indication that like we probably don't need it to be this. And sometimes maybe you're like, well, yeah, but I'm going to use it in another place. And if that's true, then I think fair enough. But I feel like that's at least a place to have a conversation. If it's like, we're only using this here, we don't need to keep it separate or have it 3 different functions.
I love that, Kevin. That is so data driven. And I did go in the day. I did look at the classes. Hey guys, there's absolutely no reusability at all, and there never will be because of the way data pipelines are structured. Maybe it's time to think about how we want to refactor this to simplify the developer productivity, because we are adding pipelines every single day. And I believe I can halve or reduce it by 2/3 the amount of time it takes to add a pipeline and write tests for it and run smoke tests and integration tests for it if I simplify it. But yeah, thank you, Kevin. That's fantastic suggestion.
And I mean, if once, if you bring it down to a single function, and then I think an area where it's like, yeah, we probably should combine this into one function that gets shared across these multiple, is if you're ending up with like very specific, like multiple specific functions that are all doing like pretty similar stuff, but just a little bit different. Then I think it's like, oh, we've went too far in the single file direction. I think, yeah.
I think so. And so I've tried. Oh, sorry, go ahead.
Oh, you're fine. I think the other part of that too is something that's really easy to think about when you're fresh in a framework is, oh, well, this idea is going to be used in 16 different places, right? And so we're going to make sure that it has this cool class setup and a bunch of inheritance because we're going to reuse it. And I'm not sure if the book that talks about this or if it was a different paper that talked about it or a different book. But when you're building these frameworks, it is really easy to just add new ideas in. It is a lot harder to remove them, right? Because if you fully remove an idea, you're going to have to deal with backwards compatibility. You're going to have to deal with deprecation cycles. And so it took you 1 week to add this new class idea, this new inheritance idea. It's going to take you like 3 months to fully remove it from the code base. And from what it sounds like, this might have been something that was there from the beginning.
It was. That's how the infra depends on this structure. So the infra that runs this pipeline depends on these abstractions. But my argument is that these abstractions shouldn't be forced on the developer. So we rebuilt another package that was similar, another package for data pipelines, and now everything is a single class. Everything is a single way. But of course, there are cons in that as well. People said that it's too easy for someone, an intern contributing something, to break everything. If someone just needs to change the script, they could break everything else. So now I'm trying to figure out how we can marry both and get to the best of both worlds. But my view is that the constraints of the infra shouldn't be pushed onto the developer. And I think the book talks about this in terms of the interface versus implementation. We should have a simple interface, as if the implementation can be as complex as it needs to be, but the interface should be simple for the developer.
Yes, exactly.
Is this deep classes?
Exactly. So thanks for letting me take a go off tangent, Zach. I wanted.
Oh no, it was a great discussion. I love this. It's phenomenal. Yeah, I mean, as LZ mentioned, like I think I think literally the next chapter talks about abstractions, modular design, deep modules, and shallow modules. And yeah, this would be, the idea of a shallow, I think it's like shallow interface with deep modules, right?
Many shallow interfaces. This is many shallow interfaces. Instead, we should have one interface that supports very deep functionality.
Yeah.
I love you making me read this book. Now I have this vocabulary to push back against my senior SDEs, because I'm just a scientist, right? And they're like, hey, what do you know about software engineering?
I mean, my major was literally software design. And this book still has some things that like my professor didn't teach. It taught a lot of it because my professor was like, here's clean code. We're going to throw it out the window. It's terrible.
Wow.
But even then, because like we talked about complexity in that class, in those classes, and we talked about like designing modules to a certain extent, but the level that this talks about are kind of areas where I already know that my degree field was very different and talked about a lot of things that other classes did not, and other degree fields in general. This stuff is still like, when you read it, it's like, well, of course, that makes sense. But no one ever said it out loud, except for you in your head.
I wonder if you need time building OSs like this, the author did, in order to make those mistakes. And then with the hindsight of 18 months or 5 years, realize that it was a mistake and how to improve on it. And then make a new set of mistakes. And then with the hindsight of experience, over and over and over again, that you come up to this set of very clean, valuable principles. I wonder if that's essential in order for you to get that. And we are just reading from his distilled knowledge, so we don't have to repeat his mistakes.
I mean, that's kind of what you hope out of anything. Like, I know, this book also talks about like throwing clean code under the bus, but like clean code was also the same way. And so to a certain extent, it's like, back in the day, clean code was also there for like strict software engineers, and that's where it was, right? It was dry. And then
can you define clean code? What does that mean?
Oh, clean code is a book.
Okay.
And basically what the book defines is you should never repeat yourself. You should have a million things that do one thing. And if you have, yes, Uncle Bob. Everyone loves Uncle Bob. Code should be readable and should never need comments. Code should be pretty. And if you have long lines and long lines of code, you have issues. Gotcha. I don't know. Some parts of the book are good. you see it especially in like JavaScript, because JavaScript is fully defined in a single line most of the time. But for Python programming, and especially like user interfaces and stuff like that, it has less relevance than to say like functional programming, I think, in my opinion. My opinion can be wrong, and that's okay. But that's sort of where I've thought about with it at this point. It's certainly a good read that you should read at some point. Yes, Pragmatic Programmer is a much better one in my opinion.
Oh, thank you.
Yeah.
I was struggling with that. I kept pushing back, hey, I think we should be pragmatic instead. I love that book, The Pragmatic Developer. And I give it to all my new applied scientists that join. Hey, please read this. We're gonna talk about summaries of this.
Yeah, I think I had to read Pragmatic Programmer as part of college, actually.
Wow, that's very forward for your college.
Yeah, because it was like we had to read Pragmatic Programmer, we had to read, and then what was the other one? We had to read this book called Release It. That's literally all about production grade software.
Nice.
So like the first chapter is literally on stability. And then it's a whole bunch of case studies on like how do you deal with outages, what are stable design patterns. It actually was a really good book, and I thoroughly loved it. I'll throw it in the Discord. It's a chunky boy.
I mean,
like, 300, 400.
once we are done with philosophy of software design, who says we have to stop there?
Oh God,
we should just pick the next book. Yeah. So I guess we have a couple of minutes left, Zach. I wonder, what is your challenge to us for next week? How many chapters should we read? Clearly, one's not going to be enough.
Yeah, one's not going to be enough. I forget like how short these chapters are. I mean, getting through chapter 4 and chapter 5 would be good, and then just build something. Like document yourself building a framework. Like that's why I showed an example with PyTorch. Like expand on it. I'll expand on it to make it a bit more complex, but like start with the absolute worst code base you can possibly build, and then make small iterations with each of these ideas, both the good and the bad examples, and just see what that looks like. So like I'll be looking at how do I make an overly complex API, right? That is too many layers deep. Document like, well, here's what the stack traces wind up looking like whenever I have that, versus writing a simple code base that adheres to these ideas of like careful abstraction, careful module design, deep modules, shallow modules, and also try and like find a few code bases that we can study as well. The smaller the better, I think, would be sort of a good idea of things to start thinking about for next week. And sort of practicing would be good. And it's okay if you can't think of any and you're trying and you can't quite find any. That's why I'm trying to come up with like a general code base we can all look at and study from to practice things. That's in PyTorch, because at least a majority of us are familiar with PyTorch, and if not, you can see it and you don't have to understand what's going on. Just understand these are the things I need to write and have happen. I think that'd be good. Was there any other ideas anyone else had on other interesting ideas or topics or ideas to sort of help the group along? Okay, cool. In that case, let's just roll with that then. It was awesome. I'll go ahead and get a screenshot of everyone here, so that way Twitter can know just how many amazing computer scientists we have here that are going to be doing amazing at building projects now. But thank you guys so much for joining this week. This was a lot of fun. A lot of interesting discussions that I've kind of missed having were happening here, and I love that.
This motivated me to get my GitHub Actions working again for a project that it's been like 8 months since they've worked, and it's like whatever. I'm the only one in it, and it's like, okay, fine, I'll do it.
Good. Yes, we love the practice.
Thank you, Zachary, for doing this.
Yeah, absolutely. I've kind of wanted to do this for a while, but I never quite had the motivation or time. So it's like Sure, why not? We'll put this on just before the holiday season. What can go wrong?
Sorry, Zachary, in case, I don't know if you've done this before, do you have some sort of a route map for somebody who's trying to just catch up? Some of us have been a little bit slow. We've been on it for 5 years, but we feel so many people have come and overtaken. That's what I think. So is there kind of a route map so that somebody who wants to catch up, like maybe you want to catch up on an API or like Fast AI or PyTorch or whatever it is that somebody's interested in?
Sure. I'll send a few tutorials for PyTorch. Fast AI and things. My hope with how the study group goes is you just need to understand what the interface looks like. So that way you can see how complex some things are and simplistic some things are. If you want to go study them and learn them, that's perfectly cool. Otherwise, I'll send some tutorials for PyTorch. Because, you know, at the end of the day, it should just be, we're going to look at a code base, and without knowing anything about it, is it good? Or am I smelling things that smell bad? Because at the end, that's kind of where I'm hoping we can all get to. Because, you know, I think chapter 1 even, or it might be chapter 3 said this directly. It's easier to smell issues in other people's code than it is in each other's or than in ourselves. So like, that's why I want to see everyone build these sort of mini APIs, because then we can share them and then compare notes and be like, well, you did this. Why did you do it this way? This looks weird and is complex to me. So I'll put some resources down in the Discord for us all, and we can sort of go from there. That sound all right?
All right.
Perfect. All right.
That's great.
See everyone next week.
All right. Bye-bye.
Thank you.